try this one for me. Solve it. I give you guys 2 minutes, 5 thumbs up. Okay. I wish you guys can still remember this formula. Okay, now I'm gonna write down the answer on board. So for these problems, the first things you need to know what is px and what is fx, right? So px equals -2 and fx equals 3, right? And also I put the formula here in case you guys forget it. Sorry. We have the formula like that. So the idea is write down the px and fx, and then we calculate the integral. Is this integral this integral equals what? This integral equals negative 2x. And then we plug into the formula here, c e negative 2x plus e negative 2x. E is negative 2x. Fx is what? Fx is the 3, right? And now you can solve it. And the 3, you can put the 3 outside. Basically, what we're going to do is this guy. How to solve the integral of this guy? I tell you guys before, right? The antiderivative of this guy is divided by a. Let's see, is this guy. In the last class, I taught you guys that one should be here, right? Like that. So here the a is negative 2. That's the antiderivative of this guy. And the constant we put outside. Okay. So we can simplify it. Okay, that's it. And I'm gonna give you guys the one more example, and I wish this time everybody can make it. Okay, can make it. What I like to write down is okay, like that. Try it again, and this time you guys should make it. We did so many examples. Did you get it? Okay. Now let me write down the answer on board. Px for fx equals negative 8. So we do the integral for this guy. I'm gonna do it a little bit faster because it's a routine procedure. So we're gonna have the integral of this guy. We then plug in fx is -8. And then we move this constant outside. And this guy will be this one. 2. Okay, that's it. Now I'm gonna move a little bit a harder one. Okay. Now let's take a look. This guy. Example 3. Okay. Now before I solve this guy, I have a question. What is a px? What is fx? You need to use the formula, right? Use this formula. We need a px, fx, right? So for this ODE, what is the px and fx? What? They tell me what is px? Stefan, what's your okay. -4? Agree? That's wrong. Okay. It's very clearly it's not a standard form. Standard form is df dy over dx. There's no coefficient. No coefficient x here. Huh? We always keep the first term coefficient equals 1, right? You need to be careful. The formula only solve the standard form. Okay, that is not a standard form, so we need to transform it. Okay, be careful. So we divide by x for both sides. Did you see it? Okay, now it is standard form, and we can write down the px and fx. And fx is this guy, okay, this guy. And now we can follow the same strategy. The first step, do the derivative. And this guy, what is the derivative of this guy? What's the antiderivative of 1 of x? Okay, I know it's some of you guys already forget it. It's a very special one, huh? So that's it. And then we're gonna plug in the formula. Fx. And we'll plug in the derivative of px to the formula. We got this one, right? And we can simplify. Okay, we can simplify to this one. And be careful, the e to the 4 lam x can be written down lam x to the 4x, right? Because this is lam logarithm. So gonna be x to the power 4. So what is this guy equals to? Here's the exponent, here's the lam. Should be x to the power 4. So we can tell if we write down like that, I gave you guys one extra point, one extra step. And this guy will be what? This guy will be cx to the power 4 so cx. Now the problem is boils down to how to solve this guy. Any idea? That's a very typical integral. Should be integration by parts. You guys should learn it. U dv gonna be uv v du, right? U du. So for this guy, we have what? We put the e to the power x behind the d, gonna be the antiderivative of e to the power x gonna be itself. So when you put the e to the power x to the behind the d, that means we find the antiderivative of e to the power x. That equals itself. Okay, we move back equals itself. So we can just follow this formula. Okay, follow this formula. Oh, sorry, like that. Oh, that's right. That's right. U times V. So X and switch. Right? The value of U dV equals U times V subtract V du. Okay. And then we have what? We have right? The antiderivative of this guy will be e to the power x. We can simplify it. That's it. That's it. Okay. We simplify it. Now I'm gonna give you guys an example. Later you guys try it. So try this one for me. Oh, sorry. Try this one. It's too powerful. Very similar to the previous example. I want you guys can solve it by yourself. Okay. Okay. Now I'm gonna write down the answer on board. Let's take a look. The first step, divided by x for both sides. So you can tell the px and the fx. Right. Now the second step, you're gonna do plug in the formula. Oh, sorry. We're gonna do the integral, right? In this good. We have this guy, right? This guy. Okay, we got this guy. We're gonna plug in to the formula. The fx, you're gonna get this one. And now you can simplify it. And you can see that is this guy. So we have what? We have x squared, c x squared, right? And then we're gonna get what? Right. Then we do the integration by parts. That equals and we have of course okay, that's the solution. Is that clear? factor solution. Now I'm gonna give you guys an IVP problems. So basically, we do the same things, but we change a little bit. Um, okay. Now I want to give you the initial condition, that is one. Okay. So solve these IVP problems for me. So you're gonna follow the steps. You're gonna get uh, the the solution for this guy, right? And then plug in this initial condition to get the value of C, right? So try it by yourself. You get it? You get it? One more minute, okay? It's. I think it's not too hard. Too hard. Okay. Okay, I'm gonna write down the answer on board. The first step, we're gonna solve the ODE. Then we're gonna, after we solve the ODE, we're gonna plug in the initial condition. We solve the C, okay, C. Now, if you have the C, you plug in back, you're gonna get the solution for the IVP, right? So let's just solve this ODE firstly. We simplify it, and px fx. So we have this guy and plug in. I wish you guys can memorize it because I memorize it. So we have the fx. So that's the formula. We got what? We got ln e we have x to the power -1 x -1 1 -1 plus 1 is x to the power 0. X to the power 0 should be 1, right? And answer. What's the derivative for this guy? The self, right? So this time, save you guys a lot of times because it's not integration by parts because we cancel out the x. Did you guys try the integration by parts? That's the antiderivative of e to the power x equals itself. That's it. Very simple. Okay, so now you got the solution for the ODE. Now you're gonna plug in the initial condition when x equals 0, y equals 1, right? So x equals 0. Oh, I make a mistake. Should be a 1, 1. Sorry. So when x equals 1, y equals 1. Sorry, I make a mistake. So x times 1 equals 1. Okay. And the c, you can solve the c is 1 minus e. And plug it back, you're gonna find the solution is c. Is the solution of AEP. Okay, that's it. That's it. Now I'm gonna give you guys the last example. Solve this guy for me. Okay. dy over dx plus 1 equals h. Okay, did you get it? Oh yeah. What's the problem? Why equal to what? Okay, I'm gonna write down the answer on board. So the first step, you're gonna find what is a px. Come on, px is the coefficient of the. Okay, so make sure you guys write down correct correct px and fx. So follow the steps. All right, so that's the antiderivative and plug in fx. How to do the integral of this guy? Integration by parts, right? So we have and again, we can simplify it. This is times this guy gonna cancel out, times this guy cancel out. We're gonna do this one. So that's the solution for the ODE. Now we're gonna use this initial condition when x equals 0, y equals 4. So plug in 0, right? And c equals 5. Okay. So the solution for the IVP should be plugging that. Plugging that, we're gonna get. Okay, that's it.